Today we will do some questions on factorizing the polynomials, and we have to decide in a given polynomial which identity is to be used. So these are based on the identities that we have done in this chapter of polynomials. So now look at the question given here: a cube minus 8b cube minus 64c cube minus 24abc. When you look at this expression, see there are 4 terms in this expression. 1, 2, 3, 4. You know, whenever there are 4 terms and you can see some cubic terms in the expression, you can think of these 4 identities that I have written here. One is a plus b whole cube, because in a plus b whole cube you get 4 terms, but 2 of the terms are cubic terms, the other 2 are not cubic. A minus b whole cube, again here 4 terms, 2 terms are cubic. And the third one, a cube plus b cube plus c cube minus 3abc. Here also there are the 4 terms, but 3 terms are cubic terms here, and 1 non-cubic term is also there. Whereas in conditional identity we get this 3 cubic terms only, and then we get the answer as 3abc. So if you look at the given expression, how many cubic terms you can see? 1, 2, 3. And along with 3 cubic terms we have one more term here. So which identity out of these 4 do you think it matches the most? And that is the third one. So that is what we are going to use here. This is a cube, means a whole cube, and you know this is a cube plus b cube plus c cube minus 3abc. This identity we are going to use here. So in between I have to use a plus sign. I have to take this minus 8 inside the bracket. Minus 8 is the cube of minus 2 and then b. So minus 2b whole cube. Similarly, minus 64 is the cube of minus 4c whole cube. From here you can decide what is your a, b and c. A is a only, b is minus 2b and c is minus 4c. Now let us check out that do we get the last term in the form of 3abc. 3 into a into b into c, and now check out does it match this term. So minus and minus will become plus and this will remain minus only. So 3 into 2 6, 6 into 4 is 24, abc. So this term is, it means the entire expression exactly follows the format of the third identity, that is a cube plus b cube plus c cube minus 3abc. Now we know our abc, so let's write this expression in this format, because this is the factorized form. There is a product in between the 2 brackets, so this is the factorized form of the given expression. So first bracket should be a plus b plus c. So what will you write? A plus b plus c. This is the first bracket. In the second bracket you have a square plus b square plus c square minus ab minus bc and minus c. Now let us check out, are these terms matching? No, sorry, we don't have to match it now. You simplify and get the answer. So you'll get here a minus 2b minus 4c in the first bracket. Second bracket will be a square plus 4b square plus 16c square. I hope you understand, whenever there is a square on the negative sign it becomes positive. Then this minus and minus will become plus 2ab. Then minus and minus plus, and plus and minus is minus. 2 into 4 is 8bc, then again minus and minus plus 4ca. So this is the factorization of the given algebraic expression. Now let's take another question. A cube minus b cube plus 1 plus 3ab. Again, if you observe, there are 4 terms and some cubic expressions, but how many? At a glance you feel there are only 2 cubic terms. So if there are 2 cubic terms, we can think of using a plus b whole cube or a minus b whole cube, because here there are only 2 cubic terms in these 2 expressions. But exactly, do we have 2 cubic terms or 3? don't miss out these terms like 1 or only 27 is written or 64 is written or 343 is written, means they are the cubes of some numbers. So they can also be treated as a cubic term. So what should I do here? I will write this expression as this is a cube plus minus b whole cube plus 1 cube. Other than 3 cubic terms, we have one more term. That means we can use the third identity, that is this one. Other than the cubic terms, you have minus 3abc kind of a thing also. So minus will follow the identity minus 3abc. So 3 into a, in place of b I have minus b, and c is 1. Now check, is it matching this term or not? Plus 3ab, yes, it is matching. So it means it is exactly following the format of the identity a cube plus b cube plus c cube minus 3abc, which is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. You must learn the identities well. So now what can it be written as? A plus b plus c in the first bracket. So a plus b plus c. Second bracket is a square plus b square plus c square minus a into b minus b into c minus c into a. So the answer is a minus b plus 1 into a square plus b square plus 1. Now this minus and minus will become plus ab plus b minus a. This is the factorization of the given algebraic expression. Let's see one more question here, that is under root 2 a cube plus 8b cube. It's not under root, it's 2 root 2. 2 root 2 a cube plus 8b cube minus 27 c cube plus 18 root 2 abc. Look at the question and don't get tensed how to look after these root signs and plus and minus. No, just have a rough idea of which identity we can use here. Again, in this expression there are 4 terms and we can easily see they look like 3 cubic terms. In the beginning we see that. Other than 3 cubic terms, we have one more term which may be of the type 3abc. If you don't have the 4th term, this one, and only 3 cubic terms, then we can think of applying the conditional identity. And if there are only 2 cubic terms, we can think of applying a plus b whole cube or a minus b whole cube. So with cubic expressions, you have to follow these points. Now 2 root 2 a cube, just with the practice only you will get to know all these things. If I write root 2 a whole cube, what will I get? Root 2 a whole cube means you do the cube of root 2 and you do the cube of a. Now root 2 whole cube means root 2 into root 2 into root 2 and a cube. Now root 2 into root 2 will give you 2 into root 2. So 2 root 2 a cube. Right? With the practice you will come to know of these things. So 2 root 2 can be written as root 2 whole cube plus, now 8 is the cube of 2, 2b whole cube plus, even if there is a minus sign, we also always have to put plus sign. So minus sign will be taken inside the bracket, minus 3c whole cube minus a cube plus b cube plus c cube minus 3abc. Here a is root 2a, b is 2b and c is minus 3c. Check out this last term, is it exactly matching with this term? Minus and minus will become plus, and 2, 3 is a 6, 3 is a 18 root 2. 18 root 2 abc and with a plus sign. It means it's exactly following this identity a cube plus b cube plus c cube minus 3abc. So that is equal to a plus b plus c. That will give me this as a first bracket. Second bracket is a square. So that means root 2a whole square. Let me put a big bracket, square bracket here. Plus b whole square plus c whole square minus a into b minus b into c minus c into a. And after simplifying we get root 2a plus 2b minus 3c. Inside the bracket we get root 2 whole square will be 2 only. So 2a square plus 4b square plus 9c square minus 2 root 2ab plus 6bc plus 3 root 2ac. And this is the factorization of this expression. And now the next question is 64 upon 125x cube minus 8 minus 96 upon 25x square plus 48 upon 5x. Again, as you can see, there are 4 terms in this expression and one cubic term you can easily see. Can you locate more cubic terms in this expression? Yes, this 8 is the cube of 2. But no other term can be a cubic term because here it is x, here it is x square, so these can't be the cubic terms. So it means in the given expression we have only 2 cubic terms. 64 is the cube of 4, 125 is the cube of 5 and then x and then whole cube. 8 is the cube of 2. So at least we have a cube minus b cube. And you know what is the identity? A minus b whole cube is a cube minus b cube minus 3a square b plus 3ab square. So let's try and write the other term in the form minus 3a square b. 3 into a square into b plus the last term is 3 into a into b square. Now check out, is this term exactly giving you this expression? So when you open it out, you will get 4 4s are 16, 16 into 3 is 48, into 2 is 96. So in the numerator you will get 96 and denominator 5 square will be 25 and then x square. So this term is exactly matching with this term. The last term, this let us check out. This is 3 into 4 is 12, 12 into 4 is 48 divided by 5 into x. 48 upon 5x is exactly matching this. So it means it is following exactly the format of this identity. A cube minus b cube minus 3a square b plus 3ab square. So this expression can be written as a minus b whole cube. But what is our a? 4 by 5 x. And what is b? 2. So a minus b whole cube is 4 by 5x minus 2 into 4 by 5x minus 2 into 4 by 5x minus 2. This is the factorization of the given expression. Moving on to the next question. This is b cube minus 27q cube. This easily resembles a cube minus b cube. Here it is b whole cube and here it can be written as 3q whole cube. So what is your a? B, and what is your b here? 3 cube. A cube minus b cube, you know the formula, it is a minus b into a square plus ab, which is 3p cube, plus b square, which will be 9q square. I have directly applied the formula that I think all of you can do very easily. There won't be any problem in that. Now moving on to the sixth question. It is x cube upon 216 plus 8y cube. Again you can see 2 cubic terms with plus sign in between. This can be written as x upon 6 whole cube plus 2y whole cube. Can we treat this as a cube plus b cube, where a is x upon 6 and b is 2y, and the identity for a cube plus b cube is a plus b into a square minus ab plus b square. So let's write it in this format. A plus b will be x by 6 plus 2y. This is a plus b. Then a square minus a into b plus b square. When you open it out, you will get x square upon 36 minus xy upon 3 plus 4y square. This is a very simple example. So question number 7th is 54 x to the power 6 into y plus 2 x cube into y to the power 4. Now when you look at this expression, you will feel that it is not matching any of the identities. In such situations, what you should do is you must look for something common in the terms. If you can take out common, maybe whatever is left inside the bracket comes out to be some identity. Okay, it will start resembling some identity. So let us look at the constant numbers. If you take out 2 common, okay, then from x, here the power of x is 3, here the power of x is 6, the lowest power is 3, so we'll take it out. Power of y is 4, here the power of y is 1, so the lowest power is 1, that we will take out. Now let us see, after taking this common, what are we left inside bracket? 54, 27 into 2 will give you 54. Out of 6 powers of x, 3 powers have been taken out and 3 are still inside the bracket. 1 power of y has already been taken out. From the second term, 2 is already out, x cube is already out, y, out of the 4 powers of y, 1 power of y is out, so we are left with 3 more powers inside the bracket. Now if you look at the bracket, the outside term will remain as it is. Look at the bracket now, this resembles a cube minus b cube now. We can write 27x cube as 3x whole cube and this is y cube, a cube plus b cube. So apply the identity, this is a plus b into a square. A square will be 3x whole square, which I am directly writing now, 9x square minus ab, so 3x into y plus b square, which is y square. So this is the factorization, 2x cube y into 3x plus y into 9x square minus 3xy plus y square. This is the factorization of the given expression. Now one more part we'll see. Question number 8. Suppose it is x cube y cube plus 1. Again it resembles a cube plus b cube because y cube can be written as xy whole cube and 1 can always be written as the cube or the square or any power of the number 1. So here it is a cube plus b cube. What is your a in this case? xy, and b will be 1. So applying the identity, you'll get a plus b, second bracket is a square minus a into b plus b square. So after opening out, we'll get xy plus 1 into x square y square minus xy plus 1. So this is how we factorize. I think now you can move on to the next question. Let's do one more question now. A cube minus 1 upon a cube minus 3a plus 3 by a. Again we can see 2 cubic terms here. One is a cube, then minus 1 upon a whole cube. Now there are only 2 cubic terms, negative signs are there, so it might be resembling this identity, a minus b whole cube, which is equal to a cube minus b cube minus 3a square b plus 3ab square. After guessing the identity, you just have to follow the pattern. You have to check whether the given question follows the pattern of the given identity or not. So first 2 terms are following a cube minus b cube. Now let's see, minus 3a square into b plus 3 into a into b square. So let's check out, is this term giving us minus 3a? Yes, 1a will get cancelled and we'll be left with minus 3a. Here it is a square in the denominator, so 1a will get cancelled and we are left with 3 upon a. So the given identity exactly follows the pattern of a minus b whole cube. So what is your a here? A only, and b is 1 upon a. So a minus 1 upon a whole cube. That is your question. Now next question, that is 1029 minus 3x cube. Again, a cube minus b cube you can think of, but do you think that these are the cubic terms? None of them seems to be a cubic term, because here if you look at, it is x cube, but 3 is not a cube of any number. So In such situations, we should try and look for something common. Maybe the common element, when you take out the remaining terms inside the bracket, will become perfect cubes. So, is 1029 divisible by 3? If you divide it by 3, yes, it is divisible by 3. So, I will take 3 common, and inside I am left with 3 into 3 9, 3 4s are 12 and 3 3s are 9, minus x cube. So, here 3 is out inside the bracket. Now everyone knows 343 is the cube of 7. So, we have now with us a cube minus b cube. So, then you can apply the identity of a cube minus b cube. A square plus ab plus b square. So, that gives you 3 into 7 minus x into 49 plus 7x plus x square. That is the factorization of this expression. Now the next question is, suppose I take question number 11, suppose it's a square minus b square plus 2bc minus c square. Now what? 4 terms, but none of them is cubic. So forget about the cubic terms now. Let's think of something else in this case. Here, if you look at the last 3 terms, still they look connected to each other, but a square, there is nothing related to a with the remaining 4 terms. So let a square be separate. Let us combine these 3 terms together, group them in one bracket, and let's take minus sign common. So we are left with b square minus 2bc plus c square. Now the moment you write it this way, do you think that this resembles the identity b minus c whole square? Okay. After writing this, now this is the format a square minus b square, where your a will be a only and your b will be b minus c. So what is the identity for a square minus b square? It's a plus b into a minus b. So a plus b, and the second bracket will be a minus b. Hence we get a plus b minus c and a minus b plus c is the factorization of this given expression. One more I take. Suppose it's x square minus root 3x minus 6. Here it's root 3 and here you have minus 6. Does it resemble any of the identities like a plus b whole square, a minus b whole square? No. As I told you in the beginning itself, for that we need 2 perfect square terms. Here we have only one perfect square. 6 is not a perfect square, root 3x is not a perfect square. So we can use middle term splitting. Now for middle term splitting, we need the sum of the two numbers to be minus root 3 and the product to be minus 6. So how can you get the product to be minus 6? Basically, in order to get the product minus 6, okay, you can say it's 2 into 3 or it is 6 into 1. That is the only way out. But you know, simply by taking these kind of numbers, you will never be able to get the sum as minus root 3. It means whichever number you choose, if I choose 2 and 3, I need to have root 3 along with both of them. Root 3 should be attached to both the numbers, only then you can add or subtract them, and then you can think of getting the answer in root 3. So if I take 2 root 3 and 3 root 3, the product will be much more than 6, right? So you know, in both the numbers root 3 is going to be present. It means what I should do is 6 divided by 3. I will get only 2. So let me look for two numbers whose product is 2. So let's take it as 2 into 1. So if I take 2 root 3 and 1 root 3, okay, and I want minus root 3. So I'll take the two numbers as minus 2 root 3 and 1 root 3. Now what is their product? 2 into 1 is 2, root 3 into root 3 is 3. So 2 into 3 gives you 6 and minus 6 is the product. So I will be writing x square minus 2 root 3x plus root 3x minus 6. So taking out common, x is common, x minus 2 root 3 plus, here I can take root 3 common, x minus, now here it is 6. You all can understand 6 can be written as 2 into 3 or 6 can be written as 2 into root 3 into root 3. From 6, if I take this root 3 common, what are we left with? 2 root 3. Now in this bracket and this bracket, x minus 2 root 3 is common, and inside the other bracket we are left with x plus root 3. So that is the factorization for this part. Next is, say, the 13th part. If I take it is x square minus y square minus 4xz plus 4z square. Again, it is one of the same questions that we did earlier, but here see that which variable is separate, nothing to do with the other variables. Here in this case it is y square, because these three terms still have some continuity, some combination. So let's take these three expressions in one bracket and minus y square. So I can write this as x square plus 2z square, and the middle term is 2 into a into b. So what does it resemble? A minus b whole square, that is x minus 2z whole square minus y square. Now it is the identity a plus b into a minus b. So it is a plus b and this is a minus b. Now let's move on to the next question. 2x square minus 5 by 6x minus 1 by 12. So here, as you can easily see, no identity is a plus b whole square, a minus b whole square. So let's do it by the method of splitting the middle term. So here we need the product to be 2 into minus 1 by 12, that is minus 6, and sum to be minus 5 by 6. So as you can see, the denominators in both the cases is 6. So let's see which two numbers will match this combination. If I take minus 6 by 6 and I take 1 by 6 and I add them up, the denominator will remain 6 only and the numerator will be minus 6 plus 1, which will give me minus 5. And similarly, the product will be minus 6 by 6 into 1 by 6. If you see, the product will also be minus 1 by 6. So these are the two numbers which we can choose here. So we can write this as 2x square minus 6 by 6x plus 1 by 6x minus 1 by 12. Or instead of writing 6 by 6x, just write minus x. That will also be okay, because we have already checked it. Now x into 2x minus 1, and here I can take, if I take 1 by, see, out of 1 by 6 and 1 by 12, which number is smaller? Obviously 1 by 12. So I will take 1 by 12 common here, because 6 can always be written as 2 upon 12. So if I take 1 upon 12 common, I am left with 2x minus 1. So from this bracket and this bracket, I will take 2x minus 1 common and I am left with x plus 1 by 12 in the other bracket. These are slightly difficult questions, but yes, if you will practice it, it will train your mind and will be helpful for you in class 10th if you do a lot of practice of these type of questions of factorization. Now let's take another question. 9 into 2a minus b whole square minus 4 into 2a minus b minus 13. Here, can you see 2a minus b? If I simply put 2a minus b as something, say x, then my expression will become 9x squared minus 4x minus 13. Now can I do the splitting of middle term? Here I want the product to be 9 into minus 13, which is minus 117, and sum to be minus 4. So I think the breakup is very clear, 9 and minus 13 itself. So minus 13x plus 9x minus 13, or let's write it the other way, 9x square plus 9, you can write it in any way, whichever number you want you can write first. That's not necessary that you have to write this number first or that number first. Now from these two expressions take out 9x common, x plus 1. From here I'll take out minus 13 common, x plus 1. So I will get 9x minus 13 and x plus 1 as the two factors. Now here x was not there in the original question, but we had put x is equal to 2a minus b. So once you have factorized, just write 9 in place of x, put the value 2a minus b minus 13. In the second bracket also 2a minus b plus 1, and open out the bracket, 18a minus 9b minus 13 into 2a minus b plus 1. So that is your answer basically. Then let's look at the next question. 1 minus 2ab minus a square plus b square. Here if I just open out this bracket, I will get this. Now you can see again these three terms have some connection in between. So let's take minus sign common, 2ab plus a square plus b square. Now the moment you put them in bracket, you can see this, they resemble the identity a plus b whole square. Now this one can also be written as 1 square. So now we can follow the identity a square minus b square. So a plus b in one bracket and a minus b in the other bracket, which gives you 1 plus a plus b into 1 minus a plus b. So this is the factorization of this expression.